So nature of the root of quadratic equation. For any quadratic equation, the root to that quadratic equation from ax squared plus bx plus c equal to 0. The root to that is x equals minus b plus or minus the square root of b squared minus 4ac over 2a, in which we should have two answers to that. So we have x equals minus b plus square root of b squared minus 4ac over 2a, or x equals minus b minus square root of b squared minus 4ac over 2a. So we're going to look at the nature of this root. What does it mean by the nature of this root? The nature of the root is determined by the discriminant. The discriminant determines the kind of roots you're going to have. What does it mean by nature of the root? Sometimes when you're solving a quadratic equation, you are going to have a minus in your square root. And when you have a minus in your square root, you're going to have an imaginary root. In that way, that is not a real root. It is an imaginary root. In that way, you're going to have something like I attached to your solution. But in some other cases, you're going to have a plus, which means that the discriminant must be greater than 0. When the discriminant d is greater than 0, you're going to have a real root. So I'm going to put that out, that we're going to represent here is what we need to determine the nature of the root of that equation. B squared minus 4ac equals to d. So in that way, d will now give us b squared minus 4ac. This is what is called the discriminant. And the discriminant is the one that tells us the nature of the root that we have. So if this d is greater than 0, we're going to look at when d is greater than 0, we're going to look at when d is less than 0, and we are going to look at when d is equal to 0. These are the three discriminants that we are going to look under the root of this equation. Follow me as I go. So if we have d greater than 0, it means if d is greater than 0, in this case, we are going to have real roots, real and distinct roots. Real and distinct roots. If d is less than 0, in this case, we are going to have not real and imaginary root. And if d equals 0, in this case, we are going to have real roots and equal roots. So let me just use this opportunity to tell us a layman explanation to this. Whenever you are solving your quadratic equation and you have the square root of plus something, you have a real and distinct root. But when you are solving and you have your square root as minus square root, that one is not real and it gives you an imaginary root. What about the real root? In real and equal root is when you have a perfect square which is equal to. So the graph to this is telling you that if you have this, if you have this, if you have something like this, in which this is x-axis, and here we have the discriminant d greater than 0. In this case, this is going to give you a minimum value, and here a is less than 0, a is greater than 0, at minimum value a is greater than 0, and here a is less than 0. At this case, what are we talking about here? We're talking about when x cuts off, or where they intersect. So this side will be alpha, this side will be beta. This side is going to be alpha and this side is going to be beta. So the same thing here. This side is where the x-axis is, where the graph cuts the x-axis. So this is also going to be your alpha, and this is also going to be your beta. This is when d is greater than 0. And when d is greater than 0, you are going to have real and distinct roots. You're going to have real and distinct roots. That means that everything you have here, you have your d greater than 0 here. And also here, you have your d greater than 0 in that. So if we move into the next one, which is d is less than 0. If we move to the next one, d is less than 0. This is the graph to that. This is x-axis, and this is x-axis. It means that the x-axis does not intersect with the graph. In that way, there is no real root. In that way, there is always imaginary root. It doesn't touch it. It looks like it's going to touch it, but it's not touching it. So this is d less than 0. That means that's an imaginary. So what about the third one? The third one, when d equals to 0. So you have this, you will have this. When d equals to 0, in that way, this is your graph. This is your graph. It's touching it. So in this way, x-axis and x-axis. So this one will form a perfect square. This one will form a perfect square. So that's it. These are the three discriminant, the three nature that you can see under the root of the quadratic equation. And also mind you, here a is greater than 0, d is greater than 0, a here is less than 0, d is greater than 0, and this value here is x equals minus b over 2a. The value here is s equals minus b over 2a. Let's quickly look at this. Let's quickly look at this following quadratic equations and determine the nature of this equation. Determine the nature of the roots of this equation. Solution to this. What you have to do first is to look at this. Number 1, 2x squared minus 8x plus 13 equals 0. What you have to do under that is to compare this with the general equation of quadratic equation. We have ax squared, if you compare this, plus bx plus c equals 0. In that way, that will tell you what is the value of a. So a equals 2, b equals minus 8, and c equals 13. The reason we're going to look at this is that we know the discriminant that d is equals b squared minus 4ac. And we already know that if d is equal to 0, that's an equal root. If d is less than 0, that's an imaginary root. If d is greater than 0, that is a real and distinct root. So if you put these values into here and see and look at what will be the nature of that root. So here d will now be b squared will be minus a squared minus 4 times a is 2 times 13. So here we're going to have 64 because minus 8 times minus 8 will give 64. Minus 8, or let's say 4 times 26. 4 times 26, and that one is going to, if you use the calculator, so that one is going to give us 64 minus 4 times 6, 4, 4 times 2, 8, 24. That's 104. So this is going to give us minus 40. So minus 40 means that d is less than 0. That means that d is less than 0 because minus 40 is less than 0. D is less than 0. In that way, it shows that that equation is an imaginary. We give an imaginary root and it's not a real root. So that means that the first one is going to give us imaginary root. And the reason is that d is less than 0 because d gives us minus 40. So we move. Let's look into the second one. The second one is x squared minus 6x plus 9 equals 0. So if you compare that, we have ax squared plus bx plus c equals 0. In that way, a equals 1, b equals minus 6, and c equals 9. And we know that this is the formula in order for us to determine the nature of that root. D equals b squared minus 4ac. So b now will have a minus c squared minus 4 times a is 1 and c is 9. So we're going to have minus 6 times minus 6 will give 36 minus 4 times 9, which is 36. That means 36 minus 36, that will give us 0. So this one is a real root and equal root. A real root and equal root. So because, what is the reason? The reason is that for d to be equal to 0, it shows that for d to be equal to 0, it shows that it is a real and equal root. So that is the second one. So the third one is x squared plus 2x minus 24 equals 0. What we have to do is to compare with this. And then a equals 1 here, b equals 2, and c equals minus 24. And we know that d equals b squared minus 4ac. So b squared will be 2 squared minus 4 times 1 times minus 24. So this is going to be 4 minus, that is 1696 plus 96. Yeah, and that is going to give us 100, right? So d is 100. So since d is positive, that means d is greater than 0. So the third one here is a real and distinct root. That will give us a real and distinct root. Well, the reason also we normally check the nature of that root is for you to know if this equation can be factorizable or it cannot be factorizable.